Hello everyone, I am Shupatra Pancha, Assistant Professor, Department of Computer Science and Engineering, PhD is VP Dr. PG Halakatti College of Engineering and Technology, Vijaypur. So in the last class we have discussed something about non-deterministic generators and deterministic generators. Now in this class we'll be discussing something about freshness of a message. So whenever we do some transactions, the users or authenticated users should think about how the message is fresh. So that is the techniques based on the freshness of a message. So we'll be discussing about that. So that is what we can call it as a providing freshness. Freshness mechanisms are techniques that can be used to provide assurance that a given message is new, in the sense that it is not replay or duplicated from any other unauthorized person. Replay of a message sent at a previous time. The main threat that such mechanisms are deployed against is the capture of a message by an adversary who then later replays it at some advantageous time. Freshness mechanisms are particularly important in the provision of security services that are time relevant, of which one of the most important is entity authentication. So here, mainly the freshness mechanisms are used for the purpose of authentication of users. So here there are three common types of freshness mechanisms. One is clock-based mechanisms. Second one is sequence numbers. Third one is nonce-based mechanisms. So clock-based mechanisms, in the sense, both the authorized users should have some clock, so that at certain amount of time, one user sends some message to other user. So at the same time, other user should receive at a particular amount of time with his clock. So there should have some synchronization between the users. Then second one is sequence numbers. So both the users or multiple users will be using some sequence numbers, appropriate sequence number, maybe in some order for receiving and sending up some such messages. So in that case, again, we'll be taking care of the message is fresh. Then the third one is nonce-based mechanisms. This is something like we'll be calling something about OTP. So here, one-time value will be sent to the particular receiver, and based on that one-time value, one-time data. So what we can consider is the message is once again fresh. So there are three common types of freshness mechanisms. One is clock-based mechanisms, sequence numbers, nonce-based mechanisms. So what is exactly clock-based mechanisms? Let us go uh, in brief about clock-based mechanisms. A clock-based freshness mechanism is a process that relies on the generation of some data that identifies the time that the data was created. This is sometimes referred to as a timestamp. This requires the existence of a clock upon which both the creator of the data and the anyone checking the data can rely. Say there is one example given here. So again, we will be considering the same actors, that is same users, Alice and Bob. Assume that Alice wants to send some data or send some message to Bob. So in this case, both Alice and Bob should have a clock, so that Alice includes the time on the clock when she sends the message to Bob and Bob receives the message. He checks the time on his clock, and if it matches Alice timestamp, then he accepts the message as fresh. So this is what clock-based mechanisms. So at the same time, what I can say is clock-based mechanism should also have certain demerits. So clock-based precedence mechanisms seem a natural solution. However, they come with four potential implementation problems. So what are those potential implementation problems? So very first point is both the users must have clocks. That is existence of clocks. So Alicia and Bob must have clocks for many devices such as personal computers and mobile phones. This is quite reasonable. It may not so reasonable for other devices such as certain types of smart token. Then there should have some synchronization between Alice and Bob. Alice and Bob clocks need to be reading the same time or sufficiently close to the same time. The clocks on two devices are unlikely to be perfectly synchronized since clocks typically suffer from clock drift. Even if they drift by a fraction of 1 second each day, so this drift steadily accumulates. So overall, what I can say is both the clocks must be synchronized. So one solution might be only to use highly reliable clock, for example, one based on a widely accepted time source, such as universal time. So another solution might be to regularly run as a resynchronization protocol. So this is what the second one, that is synchronization. Third one is communication delays. It is inevitable that there will be some degree of communication delay between Alice sending and Bob receiving a message. The last one is integrity of block-based data. Bob will normally require some kind of assurance that the timestamp received from Alice is correct. So this can be provided by conventional cryptographic means, for example, using a MAC, that is message authentication code or digital signature. So, however, such an assurance can only be provided when Bob has access to the cryptographic key. So there are four demerits. So what I can say is one is existence of clocks, second one is synchronization, third one is communication delays, fourth one is integrity of clock based data. So these four will create a problem while implementing clock based uh, freshness messages. Next, we have sequence numbers. In applications where clock based mechanisms are not appropriate, an alternative mechanism is to use logical time. Logical time maintains the order in which this is just like I think we have discussed something about different types of protocols, say in data communications. So those are stop and wait protocol, then automatic repeat request protocol. So like that selective repeat protocol. There are so many protocols we have discussed. Those protocols should work based on the sequence numbers. So the same concept used in this. That is the one type of techniques which gives the freshness of a message. The logical time maintains the order in which messages or sessions occur. It is normally initiated by a counter or sequence number. An example, the same example, suppose Alice and Bob regularly communicate with one another and wish to ensure that messages that they exchange are fresh. Alice can do this by maintaining two sequence numbers for communicating with Bob, which are counters denoted by NAB and NBA. Alice uses sequence number NAB as a counter for messages that she sends to Bob, and sequence number NBA as a counter for messages that she receives from Bob. Both sequence numbers work in the same way. So that is what should receive should send the same order. That is what we can call it as a sequence numbers. So this is just a scenario here, how it works. We just go through it once. When Alice sends a message to Bob, so what Alice can send a message to Bob. Alice looks up her database to find latest value of the sequence number, that is NAB. Suppose that at this moment in time NAB equal to, so Alice will be assigning that time as T new. Alice sends her message to Bob along with the latest sequence number value, which is T new. Alice increments sequence number NAB by one. That's what I said. That is, it works based on the stop and wait protocol. In other words, she sets NAB equal to T new plus 1 and stores the update value on her database. This update value will be the sequence number that she uses next time that she sends a message to Bob. When Bob receives a message from Alice, Bob compares the sequence number T new sent by Alice with the most recent value of the sequence number NAB on his database. Suppose this is NAB equal to T old. T new is greater than T old, then Bob accepts the latest message. If it is less than or equal to T old, then Bob rejects the latest message from Alice as not being fresh. So very simple concept of using sequence numbers. At the same time, how exactly that clock-based mechanisms use some of the demerits. So here, how this sequence number overcomes that clock-based mechanism. Sequence number address the four concerns that are raised with clock-based mechanisms. Existence clocks. The communicating parties no longer require clocks. Synchronization, communication delays. So these only apply if messages are sent too frequently that there is a chance that two messages arrive at the destination, the reverse order to which they were sent. So in order to stay synchronized, communicating parties need to maintain a database of the latest sequence numbers. So integrity of sequence numbers, just as for clock-based time, an attacker who can freely manipulate sequence numbers can cause various problems in any protocol that relies on them. The sequence number should have some level of cryptographic integrity protection when they are sent. So here, what I can say, even if there is a delay, doesn't matter. Even if it is not synchronized, doesn't matter. But integrity should be there for sequence numbers. That is must. So which one is required, which one is not required? So that is explained in this particular sequence number. So what I can say is sequence number hold the first three demerits: the existence of clock, synchronization, communication delays, but doesn't. Anyhow, the integrity for sequence number is required. I mean, it should be encrypted. The sequence number itself should be encrypted. That is integrity of sequence numbers. Then last one is nonce-based mechanisms. So one problem that is shared by both clock-based mechanisms and sequence numbers is the need for some integrated infrastructure. This problem solved using a mechanism called nonce-based mechanisms. So that is what I can say. Even in sequence number also, so it requires that the third one, integrity is required in sequence number. Of course, sequence number holds the first three. That is, I mean, existence of clocks, synchronization, and the third one is communication delay. So their only requirement is the ability to generate nonce, literally numbers used only once, which are randomly generated numbers for one of use. That's what I can say. OTP. The general principle is that Alice generates a nonce at some stage in a communication session. If Alice receives a subsequent message that contains this nonce, then Alice has assurance that the new message is fresh. So whereby fresh, we can mean that the received message must have been created after the nonce was generated. Again, there is a scenario here. Suppose that Alice generates a nonce and then sends it in the clear to Bob. Suppose that suppose then that Bob sends it straight back. Consider the following claims about this simple scenario. Alice cannot deduce anything from such a simple scenario. This is not true, although it is true that she cannot deduce very much. She has just received a message consisting of a nonce from someone. It could be from anyone. However, it consists of a nonce that she so let some of the demerits, what I can say. However, it consists of a nonce that she just generated. This means that it is virtually certain that whoever sent the nonce back to her, and it might not have been Bob, must have seen the nonce that Alice sent to Bob. In other words, this message that Alice has just received was almost certainly sent by someone after Alice sent the nonce to Bob. In other words, the message that Alice has just received is not authenticated, but it is fresh, what I can say. So, always what I can say is nonce based mechanism overcomes clock based mechanism as well as sequence numbers. There is a and one here also there are some possibilities that nonce can be hacked. There is a chance that nonce could have been generated before. This is true. There is a chance, but if we assume that the nonce has been generated using a secure mechanism and that the nonce is allowed to be sufficiently large, then it is a very small chance. This is the same issue that arises for any cryptographic primitive. If Alice and Bob share a symmetric key that was randomly generated, then there is a chance that an adversary could generate the same key and be able to decrypt ciphertext that they exchange. We can guarantee that by generating the nonce using a secure mechanism, the chance of nonce having been used before is so small that we might as well as forget about it. So this is what something about the nonce-based mechanisms. Since a nonce was used, Bob is sure that message from Alice is fresh. Again, this is not true. He certainly cannot. As far as Bob is concerned, this nonce is just a number. It could be a copy of message that was sent a few days before. Since Bob was not looking over Alice should Alice shoulder when she generated the nonce, he gains no freshness assurance by sharing it. If Bob has freshness requirements of his own, then he should also generate a nonce and request that Alice include it in a later message to him. So this is what one problem occurs in this nonce-based mechanism is how Bob should accept that the received nonce is once again fresh. That number may be sent by some other person or some other intermediate hacker, or it may not be fresh. So these things will happen. Non-spatial mechanisms come with two costs. Any entity that requires freshness needs to have access to a suitable generator. Both Alice and Bob should have access to a generator. That is what I can say. That is random generator. Not the case for every application. Freshness requires a minimum of two message exchanges, since it is only obtained when one entity receives a message back from another entity to whom they earlier sent to nonce. In contrast, clock-based mechanisms and sequence numbers can be used to provide freshness directly in one message exchange. So now finally we come to the comparison of freshness mechanisms. So here we have those factors discussed here, that is synchronization needed, communication delays, integrity required, minimum passes needed, special requirements. So how we compare all this? In clock based, synchronization is needed, yes or no? Yes. In sequence numbers, synchronization needed is yes. But in nonce based, there is no synchronization. Communication delays, window needed, and in all three it is needed. Integrity required. First one it is needed, second one it is needed, but in third it's actually not required. Minimum passes needed. Yes, in clock based it is one, sequence number it is one, and non-special it is two. Special requirements. Clock is must required. Then sequence number, sequence database, and in non-spaced always it is, as I said, always the nonce are generated based on the random number generated. This is about freshness mechanisms. So totally there are three freshness mechanisms. One is clock based, second one is sequence number, third one is third one is nonce based mechanisms. So in the next class we'll be discussing about fundamentals of entity authentication. Thank you.